Now, the division algorithm. You know what this is, you just don't know that you know what it is.
Really?
But you do know what it is. And the division algorithm says this, that f of x and g of x denote polynomial functions, and if g of x is not the zero polynomial, then there are unique polynomial functions q of x and r of x such that f of x divided by g of x equals q of x plus r of x divided by g of x, or f of x equals q of x, g of x plus r of x. Now that's in the mathematical format, and all of the letters have some meaning. The q's and the r's do have some meaning. Now I'm going to pick two polynomials, and they're going to be the constant polynomials. And I'm going to say, I'm going to choose, make it life easy, 128 divided by 5. So that's f of x divided by g of x. Now, if I perform the division, I get 5 into 128. 5 divides 12 twice, that gives me a 10. Subtract, that's 2, bring down the 8. 5 divides 28 5 times, that's 25. Subtract, that gives me a 3. And we would normally say this is 25 and 3/5. Or I could actually write it this way, that 128 divided by 5 is equal to 25 plus the remainder, which is 3, divided by the divisor, which is 5.
Ooh.
This is my f of x. This is my g of x. This is what we call the quotient. This is the remainder. And this is the divisor. So what this says is I've got a division. It's equal to the quotient plus the remainder divided by the divisor. That, most of the time, is how we write a long division in algebra. So if I were to take x minus 1 divided into 2x squared plus x minus 5. What do I multiply x by to get 2x squared? You'd say 2x. 2x times x is 2x squared. 2x times minus 1 is minus 2x. And then I subtract, which changes the sign. This dumps out. This is 3x minus 5. What do I multiply x by to get 3x? It's plus 3. 3x minus 3, change sign. The x's go. I'm left with a negative 2 as a remainder. So how would I write this? I would write this as 2x squared plus x minus 5 over x minus 1 equals 2x plus 3 minus 2 over x minus 1. That's this formula right here. Take two polynomials, divide them out. It's equal to the quotient plus the remainder divided by the divisor. That's this formula right here. You know what it is. You've used it frequently. You just haven't had it in general form. Then you would say to yourself, I've got this one down, so I know what this guy is. Who's he? This says that f of x, that's this guy, is equal to q of x plus g of x times g of x plus r of x. This is how you check a division. The original function, or this guy here, is the dividend is equal to the quotient times the divisor plus the remainder. So if I wanted to check this guy out, this would say that 128 should equal to the quotient, which is 25, multiplied times the divisor, which is 5, add the remainder, which is 3. This then comes down to 125 plus 3, which is 128, and that says my division was correct. This says that 2x squared plus x minus 5 should be equal to the quotient, 2x plus 3, times the divisor, x minus 1, plus the remainder, which is negative 2. So this is 2x squared plus 3x minus 2x minus 3 minus 2, which is 2x squared plus x minus 5. It checks. Now, here's the thing. Why do we make such a big deal of it? If I take just a look at this right here, this guy has a remainder of negative 2. What if he didn't have a remainder, and that's all I had? It divided evenly. What would this be? What does it look like?
2x squared minus...
What does it look like? This would say that this would be 2x squared plus x minus 5 in factored form. That 2x plus 3 times x minus 1 would have been the factorization. The fact that we have a minus 2 here means that this is not the factorization of that. That says if I were to divide x minus 1 into that polynomial, come up with a remainder of 0, these two things would be the factorization. So that says if I know a 0, if I know one of the factors, I can find the other factor. That goes back to something that you guys forget all the time. And that would be this guy. The factorization of the difference of cubes. I know if this is x and this is 1, that I have a factor of x minus 1. The problem is we can't remember that formula. However, if I divide x minus 1 into x cubed minus 1, I get that. Because that would be x cubed minus 1 in factored form. If I know one of the factors, I can find the remaining factors. Because of this guy. With the remainder being 0. That's going to make it the big gun, which is why we come up with this guy called the remainder theorem. Remainder. Let f be a polynomial function. If f of x is divided by x minus c, then the remainder is f of c. That says this, that if x squared, 2x squared, plus x minus 5 is divided by x minus 1, in this case c equals 1, the remainder is f of 1. Well, let's see. F of 1 equals 2 times 1 squared plus 1 minus 5, which is 2 plus 1 minus 5, which is minus 2. What was the remainder when I did the division? Minus 2. Now, that doesn't have a whole lot of meaning to us in this format. However, suppose what I had something instead, and I pick another example. An example that factors. This guy factors into 2x minus 1 and x plus 1. This would say that if 2x squared plus x minus 1, if it were divided by x plus 1, the remainder is, because in this case c is negative 1. It's all like that left-right shift thing, because it's x minus c, so it would be, if it's a plus, it would be x minus a minus 1. The remainder is f of minus 1. F of minus 1 would be 2 times minus 1 squared minus, or plus a minus 1 minus 1, which is 2 minus 1 minus 1, which is 0. Now, if the remainder is 0, that says I have one of the factors. It divided evenly. Well, it is one of the factors because, remember, I took this guy, which I knew was factorable, I factored him into his factorization, then I picked one of the two factors, divided it back into the original, and I'm going to get the other guy. With a remainder of 0, this says that x plus 1 is one of the factors. And you're going to find, if I know the factors, or at least one of them, I can find the rest of the factorization. And I can factor things I've not been able to factor before. So that means if it divides evenly, then the divisor is a factor. So evenly, the divisor is a factor. Remainder not equal to 0, divisor is not a factor. And it all comes down to the division algorithm and what we call the remainder theorem. The remainder theorem basically says that if I pick the 0 of the divisor, I calculate it out, I get 0, then that divisor is a factor. If I don't get 0, the divisor is not a factor.